Suppose if you drop a body on the surface of earth from a height, the body will fall towards the center of earth. Why does it happen? Because earth is applying a gravitational force on this. The force applied by earth is known as here the gravity of the earth. Because of this force, body is accelerating towards the earth. So when the body is falling freely, it has acceleration, and this acceleration is known as acceleration due to gravity. So now we have to calculate this. Suppose this is earth center part and this is radius r, and this is the mass of earth is me and the radius of earth is re. A body is placed over here of mass m, gravitational force acting downside, that is F is equal to mg. So you know gravitational force F is equal to mg, which can be written gm m upon re square. So this m and this m will get cancelled. You will be getting g is equal to gme upon re square. So this is the formula for the acceleration due to gravity. So see here, acceleration due to gravity of the earth depends on the mass of the earth and radius of the earth. So how does the acceleration due to gravity changes when you go up the surface of the earth, or if you are going down to the surface of earth? In both the cases, you have to calculate the formula for the variation in the g. Before that, we see just the variation in the g due to shape of the earth. You know, earth has got just like not exactly spherical, that is an oval shape, it is like this. So in that case, this is equatorial radius, that we can write re, and this is the polar radius rp. So we can write here re is greater than rp. We know the value of small g, that is g is equal to gme upon re square. Re, that is actually the radius of earth, and here this I have taken equator. So re stands for here radius at the equator. So radius at equator is greater than radius at poles. So by this formula, obviously g at poles is greater than g at equator. So this is the effect of the shape of the earth on the value of acceleration due to gravity. Now see here, variation of acceleration due to gravity with altitude. It means if you are going up to the surface of earth, how does the value of acceleration due to gravity change? Suppose this is here earth, this you have taken the center point O, and this is the radius of earth. When the body is on the surface of earth of mass m, so we can write g is equal to gm upon r square. So see here, m is the mass of the earth, r is the radius of the earth. So g acceleration due to gravity on the surface. Suppose this body is taken to the height here. This is height h from the surface of the earth. Then you can write g dash is equal to gm upon r plus h whole square. So if you are going up, the value of g is changing with the height. Now we have to get this relation. So we can write g dash upon g is equal to, here we can write here r square upon r plus h whole square, because gm and gm are common, that will get cancelled. Now we can take common r in denominator, you will be getting r square upon r square into 1 plus h by r whole square. This will get cancelled. So we can write g dash upon g is equal to 1 plus h by r raised to power minus 2. If you have taken, suppose h is much more less than r, you can use binomial expression. So using binomial expansion, you can write g dash upon g is equal to 1 minus 2h upon r. So this is the expression here for this g dash upon g, and g dash is the acceleration due to gravity at height h. So, we can write this formula here now. G dash is equal to g into 1 minus 2h upon r. So, when we are going up, acceleration due to gravity is given by this expression. It means acceleration due to gravity decreases as we go up from the surface of the earth. See here in this example, a body weighs 63 Newton on the surface of earth. What is the gravitational force on it due to earth at a height equal to half the radius of earth? It means the body is going up, that is above the surface of earth, but height is equal to the half the radius of earth. So, on the surface of earth, weight of the body is, you can write here, W is equal to m into g, that is mg, and is equal to 63 Newton. And at height, this one h, we can write W dash is equal to mg dash, because g is changing with the height. In place of this g dash, we can write here m. G dash can be written gm upon here r plus r by 2 whole square. In place of h, I have written r by 2. Now, you solve it, you will be getting gmm upon, that is 3r square. So, the 9r square and here into 4. And now, you have to see here what is the weight at that height, and this is the weight here known as gravitational force. So, we can write here 4 by 9 W. So, we can write here W dash is equal to 4 by 9 into 63. So, here 9 7 that is 28 Newton. So, when the body goes up above the surface of earth at a height equal to the half the radius of earth, then its weight becomes 28 Newton. Now, here we have to see variation of g, that is acceleration due to gravity with the depth. Here, suppose this is, you have taken here earth, and this is the center O, and this is radius r, mass is m. If the body is on the surface of earth, we can write g is equal to gm upon r square. Suppose body comes here by a distance, that is a depth d at this point, then what will be the value of g? So, we can write here g dash is equal to, now when the body comes to here, this much mass of the earth applying the gravitational force on the body, and this body is inside this outer shell. Because of the outer shell, gravitational force acting on the body will be 0. So, the body is on this surface of radius r minus d. So, the gravitational force acting on the body is here due to r minus d radius. Let its mass be m dash. So, we can write g m dash upon r minus d whole square. But see here, what is the mass of this? But see here, density of earth remains constant. Mass is changing here of earth because when we go down, but density does not change. So, we can write m dash is equal to 4 upon 3 pi r minus d cube, that is the volume of this much earth, into, then we can write m upon 4 upon 3 pi r cube. This is the value of m dash. This and this will get cancelled. We will be getting m dash is equal to r minus d cube m divided by here r cube. Now, put here, you will be getting here now g dash is equal to capital G into r minus d whole cube m divided by r minus d square into r cube. This and this will get cancelled. So, we will be getting r minus d m divided by r cube. This is g dash. Now, we can take g dash upon g is equal to, so you will be getting here g r minus d m divided by r cube into, we can write here r square upon g into m. This will get cancelled, this will cancel, r square, this will get cancelled, only one r is left here. And now we will be getting over here, this we can write now this side here, g dash is equal to g into r minus d upon r. That means g dash is equal to g into 1 minus d upon r. So, the value of g changes when we go down to the earth, right, and that is according to this formula. From this formula it is clear that the value of g reduces. So, whether we go above the surface of earth or down to the surface of earth, in both the cases value of g decreases. Now, let us do the graphical study of the variation of g with the depth and with the height. So, graphically we can describe all these things here. We have done for height, it is g into 1 minus 2h upon r, this is above the surface of earth. For the depth we have done g dash is equal to g into 1 minus d upon r. If you are taking here the graph like this, and this point O I am taking here the surface of earth, and this side I have taken g. So, when we go up, the value of g reduces like this, this is with the height, but when we go down, left side I am taking here below the surface of earth, value of g reduces like this, and at the center it will become 0. So, this is the variation of g with the here depth and height.